Moving one layer down is the presentation layer. The presentation layer, when you think about presentation layer, you should immediately think about translation, because that's what the presentation layer does. At the application layer, what we see is the same thing the computer is seeing. In other words, if we're sending a file, it looks like a file. But at the presentation layer, it's being translated into something that the computer understands, but we don't understand. Because eventually, it's got to get turned into just bits, right? Eventually, it's got to get turned into offs and ons so that it can go through the wire. But at the presentation layer, we're converting whatever that file was into its little bit streams that determine how the computer is going to look at it. At the presentation layer, we have protocols and we have services like ASCII for text and like EBCDIC for text, like JPEG and GIF for picture files, like TIFF and MPEG. There are many other protocols and services at the presentation layer, but those are the most common. Those are the ones we should know for the test. And just know that the presentation layer, you should immediately think translation. That's what it's doing. It's translating. At the session layer establishes and manages and then finally terminates communication between the two devices. The session layer finds the other device. There are other layers that help the session layer. We'll talk about how all that works. But the session layer is the one that actually goes out and looks for the other device once it's determined where that device is. At the session layer, we have protocols like the Remote Procedure Call, RPC, like ZIP, Zone Information Protocol, and Session Control Protocol. Whenever computers are communicating with each other, the session layer is that traffic cop that's in charge of setting those sessions up, setting those communication sessions up, and then terminating the session when it's over. The next layer down is the transport layer. The transport layer provides end-to-end communication. The transport layer is responsible for making sure that packets get delivered to their destination. So the transport layer has devices or has services built into it that check to make sure that a packet was delivered without being damaged. If the packet was damaged, then that packet needs to be resent. At the transport layer, we have protocols like TCP, Transmission Control Protocol, which is part of the TCP/IP protocol suite, which we're going to talk a lot more about. And we also have SPX, which is part of IPX SPX. At the transport layer, we have connection-oriented protocols. In other words, they are looking to make sure that packets are delivered. It's sort of like a phone call. If I call you, you answer the phone. I say hello, and you say hello. Now, we both know that we're talking to each other. We know that that communication was delivered, and there's a three-way handshake. I called you, you answered, I said hello, you said hello. It's the same kind of thing at the transport layer. It's connection-oriented. So it's dependable communication. It's guaranteed communication. It's also resource-intensive, because of the fact that we're constantly having to check behind. Also at the transport layer, we have other protocols that can be used if we don't want to use that many resources. In other words, if we have an application that is taking care of the fact that the packets are getting delivered, and what we want to do is just get those packets over there as fast as possible and use as little resources as possible. Then we have other protocols that are also at the transport layer. We have UDP and we have IPX. UDP stands for User Datagram Protocol. IPX stands for Inter-Network Packet Exchange. Now, UDP isn't like TCP. TCP is Transmission Control Protocol, and that's what it does. It controls transmission. It makes sure that those packets are delivered. UDP is more like a broadcast. UDP is connectionless. So at the transport layer, we have both of these types of protocols so that we can work with whichever one we choose. Connectionless protocols are more like a TV broadcast. You turn on the TV and you turn on NBC. Well, NBC doesn't necessarily know that you're watching them unless you're a Nielsen family. But most of the time, they have no idea you're watching them because you just picked up on a broadcast. That's what UDP is. We use UDP when transmissions are repeated, when either they're not very important and they're repeated all the time, or when we can monitor the transmission. For example, if it's a video broadcast and we can just watch the video, we know the packets got through because the video worked. So if we can monitor a transmission in another way besides having the packets tracked, then we can use connectionless protocols. Other than that, it's not a reliable protocol because it's not connection oriented, but it uses less resources. So we've got both of those types of packets, and you should know that at the transport layer you've got both of those different types of services and both of those different types of ways to move packets.